My name is Katarzyna Hewelt and I'm a data scientist at CodiLime. Almost every day we hear about the launch of a new large language model. Many of these models are so large that running them on our local computers is simply not feasible. In such cases, using cloud resources might be a great solution. For example, AWS provides powerful tools and infrastructure to support these models. Knowing how to set up this infrastructure is a valuable skill. Today, I'll guide you step by step through the process of preparing necessary resources to successfully run LLMs on AWS. Let's get started. Let's talk about large language models, which we can divide into two categories: SaaS, also known as closed source models, and open source. First, SaaS models. Examples include OpenAI's GPT 3.5, GPT-4, or Anthropic Haiku Sonnet, etc. These are commercial products and they often require licenses or subscriptions. Moreover, their architecture, training data, and algorithms are typically not publicly accessible. On the plus side, SaaS models are easy to use because they are hosted and maintained by the providers, eliminating the need for self-deployment. Furthermore, users benefit from clear legal agreements and terms of service, providing a level of legal protection. They also come with high-level support and API documentation, facilitating easier integration. However, SaaS models have some drawbacks. A big issue is the lack of transparency, which makes it just difficult to understand their decision-making processes. Also, users rely on the model's provider for maintenance and updates, and that leads to vendor dependency. Now, let's discuss the open source models. These models are publicly available and can be freely used. Open source models have several advantages. Their public availability makes them easy to customize to suit specific needs. Also, they benefit from community support from machine learning engineers and developers. Nevertheless, open source LLMs have also some drawbacks. Security issues can arise as this model may be vulnerable. Moreover, integration can be challenging due to capability issues with existing systems, and they are intellectual property concerns. Since today's presentation is about hosting open source LLMs on AWS, let's focus on this group. Despite the pros and cons, our local machine often lacks the power to run these models efficiently. Therefore, I will soon demonstrate how easy it is to set up and host these models on AWS. While talking about LLMs, it is crucial to understand some basic terms. One of these is model size, which typically is measured by the number of parameters it contains. The size of a language model can significantly impact its performance and accuracy. In general, larger models tend to perform better on complex tasks and datasets, as they have more capacity to learn complex patterns and relationships in the data. Another important term is training data, which refers to the data set that the LLM is trained on. The quality and quantity of the training data greatly influence the model performance. As the saying goes, garbage in, garbage out. If the training data is poor, the model output will also be poor. Additionally, hyperparameters are settings that control how the LLM is trained. These settings can be fine-tuned to improve the model's performance on specific tasks. To circle back to the model size, what does it mean when we say Mistral 7B? This means that this particular Mistral model has around 7 billion adjustable parameters. These parameters are used to learn the relationships between the words and phrases in the training data. The more parameters a model has, the more complex it can be. This term is especially important because the number of parameters in the model also determines the size of the model in memory. For example, the mentioned Mistral 7B has approximately 7 billion parameters. Assuming each parameter occupies 4 bytes, the memory required is 7 billion times 4 bytes, which is equals to 28 gigs. And we are talking about that because soon we'll be adjusting our AWS resources to run some models. Before we do that, let's understand the differences between GPUs and CPUs. Okay, first, central processing units, CPUs, are the processors found in almost all computing devices. They handle a wide range of tasks, from running operating system to applications and also some AI models. While CPUs are versatile, they have some limitations with LLMs due to their limited cores, making them slower for tasks that require parallel processing. Graphics processing units, on the other hand, GPUs, originally designed for graphics, have become crucial for AI and ML tasks. GPUs have hundreds or even thousands of smaller cores, allowing them to perform many operations at the same time. This makes them much faster for training and running LLMs, as they can handle more data and execute more operations per second. Also, parallel processing capabilities makes a big difference. GPUs provide significant performance improvement for tasks requiring parallel operation, allowing for faster training and inference of large language models. This makes them the preferred choice for many AI and machine learning tasks. Let's quickly compare some key considerations between CPUs and GPUs. So, model complexity, model size plays a significant role. Smaller models or simpler tasks might run efficiently on a CPU. However, as the complexity of the model increases, the need for parallel processing grows, making GPUs a better option. Budget is also an important factor. GPUs are generally more expensive than CPUs. And next we are slowly moving towards the demo, where we will be setting up an EC2 instance on AWS. We will be using a G5 instance. Amazon EC2 G5 instances are latest generation of NVIDIA GPUs-based instances, suitable for graphic, intense, and machine learning tasks. They deliver up to 3 times better performance for machine learning inference. And today we'll be testing 2 models, Google's Flan T5 and Mistral 7B Instruct. The choice of this model isn't random. The Flan T5 base model is a smaller model with about 250 million parameters, making it suitable to run on basic CPU instance, which we'll set up first. In contrast, Mistral 7B requires more resources due to its size and complexity, so we'll be using a GPU-based instance for that. We'll access these instances from our ID, which is in my case Visual Studio Code. Let's get started. Let's first prepare the environment to test this model from Google, which is Flan T5 base. As you can see, this is a small model with 248 million parameters. And here on Hugging Face, which is a platform with many open source models available, you have model card, which contains all the important information about the model, but not only. You also have a sample code to run the model on a CPU, which we are going to use later, and GPU. What is also interesting, you have Inference API here. However, this one is not available for every single model on Hugging Face. That's why it's important to know how to set up your environment. What is also interesting is files and versions. You have to check it out, like how big the model is. So you have to choose appropriate machine to run it. And that is the most important thing about Hugging Face and how to check the model information. Let's move to AWS now. Here we have our AWS console home, where we are either choosing or searching EC2 because this is the place we are going to launch our instance. Okay, to setting up our instance, just click Launch Instance, give a name of this instance. Let's put flying test. Choose the AMI, which is Amazon Machine Image. Since this model is very small, we don't need a lot of GBs. Let's just put medium. And here we have to provide key pair name. I have some key pair already created, but let's do it together step by step. Create new key. Please put a name. LLM tests and create key pair. And as you remember, our model was something about 2 GB, so let's put 20 just in case. So we have also a space to download all the necessary libraries. And that's it. Let's launch the instance. And now the next step is to connect this instance with our ID. We successfully created our instance. This is it. And now we need our public IP address. Let's copy it and let's move to our ID, which is Visual Studio Code. And here, click on the bottom left, connect current window to host, and configure SSH hosts. Choose your configuration file, and now this is the place where you paste the public IP. The user should be Ubuntu if you are following me, as we were choosing Ubuntu MAI. And here, please provide the file path to your key. And once this is done, save it. Come back to our bottom left, connect current window to host, and choose this configuration file. We are connecting, and there we are. We are connected. We are in our machine. And now we can run our model. But before we do it, let's install all the important packages. Because this is empty machine right now, we need Python, we need transformers, etc. So let's just create a new folder. Which is just test, this one, and now we can create a file, flan tests. And to test the model, we can come back to our Hugging Face and just copy paste the code. Of course, we are running on the CPU because we don't have any GPU on our machine. Of course, right now it is not possible to run this model because we don't have appropriate libraries installed. Let's first install everything we need. Also, let's create a virtual environment, as this is a good practice once we will be installing the packages dedicated to this project. Let's create the environment. You can omit this step, however, it's a good practice to do. All right. Now, once we have our environment, we can install all the necessary libraries. As you can see, Transformers is one of them. So let's do pip install. We also need Sentence Piece and Torch. Give it a moment. Okay. Okay, we are done now. It took some time and now we are ready to run our script. As you can see, the prompt is translate English to German. How old are you? And now we are downloading the model. At the first time it also might take some time. So give it a minute and soon we should be getting the answer, which is wie alt sind Sie? Of course, you can manipulate and play around with the model and change the prompt. And right now you have a fully access to this model and you can test it. Let's move to a bigger model. Company called Mistral AI released Mistral 7B model with Apache license. And they release base version and this one, instruct version, which is like chat version. And today we will be preparing an instance for Mistral 7B instruct version. We need hardware like A10 NVIDIA GPU on AWS, as this GPU has 24 gigs of virtual memory. And here you have, of course, our Hugging Face with the model card. You can have a look and read the information about the model. And you have your files versions. And what is specific for this model and for some models on Hugging Face, you need to be granted an access to the model. And how to do so? You need to create an account and obtain a Hugging Face API key. Once this is done, we will going to provide the key while running the script. Once this is done, let's move to our AWS. Back to our AWS, to our EC2, and to our instances. We can at this point, stop this flan machine, stop instance, stop, and we will be creating a new one. As a first step, we need to select correct AWS machine. To do so, we can first visit instance type and go to accelerated computing. And as mentioned, our focus today will be on G5. Have a look. Some of them have only one GPU, some even 8. One GPU is enough for us. However, we need to be careful with memory because while running the model inference, we need to load the model first. So let's safely select this machine. That is going to be enough. Okay, let's move to AWS and click Launch Instance. Let's now call it Mistral Test. Now is the moment to select MAI. And here make sure to choose the one with already installed NVIDIA drivers. Otherwise, we need to install it manually. So choose GPU PyTorch. Oh, this one, NVIDIA driver. Confirm. And this this MAI, comes with NVIDIA drivers already and with CUDA, PyTorch, everything we need. Then the instance type, as we already discussed, is G5 4x large. Key pair, I am selecting the same key pair we've already used before. And our storage, let's just make it 100 gigs for safety. And launch instance. Also note that this G5 4x large requires 16 file CPU, which you might not have access to. In that case, please contact AWS support. They will grant you the access. Our instance is launched and now same story. All we need to do, we need to copy public IP address and come back to our Visual Studio Code. Okay. Yeah, this is our old code. Let's now connect a current window to the host and let's configure our file again. I will now call it Mistral, put a correct IP address, and everything else stays the same as I'm using the same key. Okay, save it. Connect current window to host again and right now to Mistral. Continue. Okay, we are inside the machine. So same story. We are going to create directory test where we paste our code from Hugging Face, install all the necessary packages, etc. All right, we have our test, Mistral test.py. Let's copy paste the code from Hugging Face. That's the one. Copy, paste it here, save it, and now all we need to do, we need to change the code a little. Import torch. So what we're going to do, we need to use floating point 16. Now it is using 32. We simply import torch and add torch type parameter while loading the model, because right now it's slightly too big and it doesn't really make any difference within the performance. So torch d type float 16. Okay, and that's pretty much it. Let's quickly create the environment as well, as we did previously. And once this is done, I'm already connected to my environment. Same steps. Let's just quickly install the library. It might also take some time. Once this is done, we can run our inference. As you can see, access to the model is restricted. I forgot to provide, of course, our API key. So what we need to do right now is Hugging Face CLI login and provide the API key. Yes, logging successfully. Fantastic. Let's now run our model. And again, right now we are downloading it. It might take some time at the beginning, and we soon have the recipe for the mayonnaise. And there we go. We have the ingredients, the instruction, etc. And that's it. This is how you can test all the open source models. Just prepare an appropriate environment with appropriate hardware. I hope you found this video useful, and now you know how to test LLMs, even if your machine is not that powerful. Thank you for watching, and see you in the next video.